All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is calculating molarity by mass. You are going to need a periodic table and a calculator for this one. So if you don't have those, go ahead and pause the video, but otherwise we'll just go ahead and get started. So let's start with the question of what we mean by molarity. Well, molarity is really a quantitative way of looking at the concentration of a solution. So when we have, say, for example, water, and so I'll just draw a container like this that has water in it. So in the bottom of the container then is the water. And I place some type of solid material. Let's say it's going to be, in this case, salt. Salt then would be considered the solute, and the solvent is the water. So the solid salt is going to be dissolved into the liquid solvent, water in this case. So when we talk about molarity, we're talking about the amount of the solute dissolved in the solvent. Now we always describe the amount of the solute in terms of moles for molarity, and the amount of liquid, in this case it's the water, in terms of liters. So with that information, I think we can start. Number one says this. It says if a solution contains 3.458 moles of copper 2 chloride in 1.500 liters, what is the solution's molarity? So we've talked about this molarity definition and said it's the number of moles of solute and the number of liters of solvent. When we divide those two things, we get the molarity. So in this case, they're giving me the number of moles of the solute, it's 3.458 moles, and they're giving me the number of liters of solvent. So we just divide those two. 3.458 moles divided by 1.500 liters gives us a molarity, and notice I use capital M as the symbol for molarity, and I get, to the correct number of significant digits, 2.305 molar copper 2 chloride. So this is a 2.305 molar solution of copper 2 chloride. Let's look at number two. Number two says how many moles of lithium nitrate are in 250 milliliters of a 0.30 molar solution. Well, the first thing I'm going to need to do is I'm going to need to convert this 250 milliliters into liters, because remember, molarity is not moles per milliliter, it's moles per liter. So let me do that first. It's not difficult. I'll just take 250 milliliters and move the decimal place over 1, 2, 3 places to the left. So I get 0.250 liters. That's the volume of solvent. Now let's take that 0.250 liters. I'm going to put it over 1 just to hold the place, times, remember, molarity, this capital M stands for moles per liter. That's molarity. So a 0.30 molar solution is 0.30 moles per liter. When I multiply, that allows me to cancel liters with liters and leaves me with the number of moles of lithium nitrate. In this case, it's 0.075 moles of lithium nitrate in this 0.30 molar solution. And I'm done with the second problem. Let's move on to number three. Number three says a solution is made by dissolving 95.7 grams of sodium hydroxide to make 1.00 liters of solution, or 1.0 liter solution. What is the concentration of the solution? Obviously, we want to do this in molarity. So what we're going to need to do, first of all, is know the, we're going to need to know in advance the molar mass of the sodium hydroxide. I get it by simply adding up the molar mass of the atomic weight of sodium, oxygen, and hydrogen respectively. When I do that, I get 40.00 grams per mole. That's for sodium hydroxide. So now let's go back to the 95 grams of the sodium hydroxide. If I say 95.7 grams per 1 liter, that's a way of describing the concentration, but it's not in the right unit. Remember that I need moles per liter, not grams per liter. So I'm going to say 95.7 grams per 1 liter to begin with, but then I'm going to multiply it by the molar mass. 1 mole is the equivalent to 40 grams of sodium hydroxide. That allows me to cancel grams with grams, and now I have moles per liter. That's what I want. So 95.7 divided by 1 divided by 40 gives me this number, 2.35. Notice I use the capital M to denote molarity. So that's 2.39 moles per liter, or molar sodium hydroxide solution. And that finishes number 3. Let's look at number 4. Number 4 says how many grams of potassium iodide are needed to prepare 100 milliliters of a 0.55 molar solution. Now this looks complicated, but we just need to break things down. The first thing I'm going to need is the molar mass of the potassium iodide. I'll just add potassium iodide, iodine from the periodic table, and when I do that I get 166.00 grams per mole. Check me on that. The other thing is this: I need to convert milliliters because they're telling me that it is 100 milliliters that I need to prepare. So I need to convert that into liters. Just move the decimal place over three places, and I get 100 milliliters is the equivalent of 0.100 liters. So now I'm really ready to begin the problem. I'm going to start with the 0.100 liters. I'm going to put that over 1 to hold the place, and I'm going to multiply that by the molarity. Now they're telling me that the molarity is 0.55 molar. That's going to allow me to cancel liters with liters, and I'm going to be left with moles, right? Now I've got one more step. They're asking me this question in grams, right? So they're saying how many grams of potassium iodide. So now what I'm going to do is I'm simply going to take that number of moles and convert it to grams by multiplying by 166.00 grams per mole, and that gives me, when I cancel moles with moles, 9.1 grams of potassium iodide, and I'm done with number 4. Let's go to the next one. Number 5 says this: what is the molarity of a sodium chloride solution made by dissolving 263.7 grams to make 2 liters of solution? Well, let's start with the sodium chloride's molecular weight. We need to add up sodium and chlorine to get the number of grams per mole. So when I do that, I get 58.44 grams per mole of sodium chloride. Now what I'm going to do is I'm going to take the amount of the number of grams of sodium chloride and divide it by the volume. In this case is 2 liters. So I have 263.7 grams of sodium chloride divided by 2 liters. Now remember, it's not in the right unit. Molarity is not grams per liter, it's moles per liter. But it's a place to start. So I'm going to say 263.7 divided by 2.01, and I'm going to multiply that by the molar mass of the sodium chloride, which I've already determined to be 58.44. That allows me to cancel this with this, and now I'm going to have the unit that I want, which is moles, right? So I've got moles per liter, moles on top, liters on bottom. I'll do the calculation: 263.7 divided by 2.0 divided by 58.44, and when I do that calculation I get 2.3 moles per liter. Another way to write that is with a capital M, so that means molarity of sodium chloride, and I'm done with number 5. Let's go to the last question, number 6. It says, what mass of calcium bromide is needed to make 500 milliliters of a 0.554 molar solution? Well, before we really start the problem, we're going to need to get a little bit of information about the calcium bromide. So calcium bromide has a molecular weight of, when I add up calcium and 2 bromines, 199.88. Again, check me on that, make sure that that is correct. And that's grams per mole, grams per mole. Now I'm going to need to convert the 500 milliliters into liters. Remember, you always have to have it in liters, not milliliters. So I'm going to say 500 milliliters is equal to, I'm going to move the decimal place over 1, 2, 3 places to the left, and when I do that I get 0.500 liters. So now what I'm going to do is I'm going to start the calculations. I'm going to start with a 0.500 liters. I'll put that over 1 to hold the place, and I'm going to multiply that by 0.554 moles per liter. That's the molarity of the solution. 0.554 molar solution. That allows me to cancel this with this, leaving me with moles. Now I'm simply going to convert that to grams because I'm being asked what mass of calcium bromide is needed. So I'm going to multiply that by the molecular weight of 199.88 grams per mole. That allows me to cancel moles with moles and leaves me with grams of calcium bromide. So if I say 0.500 times 0.554 times 199.88, I'm going to get 55.4 grams of calcium bromide, and that'll finish it up. Thank you very much, and I'll see you in the next one. Thank you. Bye-bye.